Now see here, velocity of electron in Bohr's stationary orbit. So we know it, mv square upon r is equal to kze square upon r square. This will get cancelled. So r is equal to kze square upon mv square. Now we have to get the velocity of here this one v here. So we know it, mvl is equal to mvr is equal to nh upon 2 pi. This is according to Bohr's theory, Bohr's concept. So we will be getting r is equal to nh upon 2 pi m into v. So we can replace the value of r over here. So that is nh upon 2 pi m into v is equal to kze square upon mv square. Now this m and this m will get cancelled, this velocity and this velocity will get cancelled. So we will be getting v is equal to kze square into 2 pi divided by n into h. So kze square into 2 pi divided by nh. So this is the velocity of the electron in the stationary orbit of the Bohr's model of hydrogen atom. So we can write v is equal to, I am writing over here, kze square 2 pi divided by nh. Now we can write here v is proportional to n. It means larger orbit, if you go to the other orbits, so outer orbits has got a smaller velocity as compared to inner orbit. So in this case here we have written v is proportional to n. If you put the value of all these constants, and for like a hydrogen atom we can take, for hydrogen atom z is equal to 1, so v is equal to ke square 2 pi upon nh for hydrogen atom. Now here everything is constant and all this. So if you are taking n is equal to 1, then you will be getting v is equal to 2.2 into 10 raised to power 6 meter per second. This is actually 1 upon 1/37th, that you can say 1/37th of the velocity of the light in vacuum, that is the speed of the light in vacuum, because the speed of the light in vacuum is 3 into 10 raised to power 8 meter per second. So here now this is the expression for the velocity of the electrons in orbit here in the hydrogen atom. Now see here total energy of electron in Bohr's stationary orbit. See here, when electron revolve around the nucleus, it has got kinetic energy as well as electrostatic potential energy. So if the electron is revolving, we can write here mv square upon r is equal to kze square divided by r square, this one cancel. So we can write kinetic energy is equal to half mv square is equal to kze square upon 2r. So this is the kinetic energy of the electrons revolving around the nucleus at radius r, where m is the mass of electron here, z is the atomic number and k is the value of, that is 1 upon 4 pi epsilon naught. Now we can calculate electrostatic potential energy also. So the potential energy can be written, that can be write actually symbol u. U is equal to minus E square upon here k we can write, that is r. So minus k we can take minus k ze square upon r, where z is the atomic number. So this is here electrostatic potential energy. So total energy we can write here k plus u, that is kze square upon r minus kze square upon 2r. When we solve it, we can get E is equal to kze square upon r, we can take common, and here we can write in this case kz square, here we have taken, this is the minus here actually, this is here over plus. So we can take kz square upon r common here, so we will be getting here minus 1 by 2. So E is equal to minus kze square upon twice of r. So this is about the total energy of the electrons revolving around the nucleus. So, now we have calculated total energy of the electron, that is minus kz e square upon 2 r, where r is variable one. So, we can replace the value of r also. Already we have calculated the value of r in previous cases. So, we can write r is equal to n square h square upon 4 pi square m k z e square. So, putting the value of r over here, we can get E is equal to minus k z e square upon 2. In place of r, we can write n square h square, and rest everything is going up. So, that is 4 pi square m k z e square. So, this is the value of E over here, the total energy. Now, we can solve it. Here this is 2. So, we can write E is equal to minus k square z square e raised to power 4 here, and this is pi square, this is 2 also here. So, pi square into m. So, minus 2k square here z square e raised to power 4 pi square m divided by n square h square. This is the total energy of the electron orbiting around the nucleus. Now, we can take over here also, we can just discuss here. If we are taking, suppose z is equal to 1, otherwise before taking the z, you put all the constant values. When you put all these values, you will be getting, because everything is constant except z and n. So, we will be getting minus 13.6 up z square upon n square electron volt by putting all values of all the constants. So, this is the total energy, where z is the atomic number. So, for hydrogen atom, we can write z is equal to 1. So, E is equal to minus 13.6 upon n square electron volt. So, for hydrogen atom, this much is the total energy which can be written here.